So now I'd like to show you a ternary diagram. And I went online and spent, well, a bit of time searching. If you have like American Ceramic Society phase diagram book, it gets a little bit easier. But here we have, and those phase diagram books, by the way, they are expensive. You're looking at thousands of dollars for these phase diagram books. But if you work in the field, it is worth it, and your future employer should probably have them available for you, assuming you're working in a national lab or industry. So here we have 3 phases, and you're welcome to pronounce if you want. Basically, these are calcium silicon titanium oxide, calcium silicon oxide, calcium aluminum silicon oxide phases. And call them WO, SP, and L. Here we have the isotherms, and these are the liquidous surfaces. And here we have those binary valleys, or 3-phase valleys, that do this. And that point, then, is our ternary eutectic. Let me grab a ruler. So I thought that we would just go through a simple example of reading from one of these. So let's pick some point. Let's say that we have, let's say we got a point here. And just try to line here. So let's start out with an initial composition that is there. So that represents 20% CaSiTiO5. So SP, and then 20% WO. And then that also means you necessarily have, if you want to, you draw it in as a parallel line, or you can just subtract to get 60% AN. So then let's say we take that, we heat it up till it's liquid, and that is at around 1,400. And the units on this are not given. The fact that it has a degree symbol makes me want to say that it's degree C. It also doesn't tell us if this is weight percent or mass percent, which will change the layout on this. So those of you that have time, you can look up the diagram, and I'm going to send this to you. It's on a Canadian website for petrology. So okay, let's say it's degrees Celsius, and we're at just over 1,400 degrees. All right, we cool down, and as we start cooling down, at some point we touch the liquid surface, and let's say we cool down to 1,350 degrees, which is the next isotherm. Well, we can identify the liquid composition now by drawing a tie line from the solid, that composition which is being formed, to our composition, and then through our composition until we reach the isotherm, where we have presumably our our tie line has cut through, and that's going to be here. So now, reading this, we want to say what fraction is solid, what fraction is liquid, and we say at 1350 degrees C, the fraction of solid is going to be equal to, that's about 10 millimeter divided by the total length of the tie line, which is 62 millimeter. And then the fraction of liquid is equal to 1 minus the fraction of solid. The composition of the liquid the solid, we know is exactly this CaAl2Si2O8 because it's a line compound with no solubility. For the composition of the liquid, though, we get from reading the phase diagram, and that tells us that we have the, what is that, about 24% of SP, and we have about, let's draw this line, about 25% of WO, which means that we have around 51% AN. And to get the exact composition of the liquid, we then say that's 51% AN, and then we have chemical formula. So we can write out what the chemical formula of the liquid is. Use chemical formula. To get that. Okay. So let's say that we continue to cool, and we cool to 1250 degrees C. So let's change colors here. Now we'll keep cooling. We touch the three-phase region, so now we have SP, AN, and liquid. 1245, well, that's a little bit further, actually, 1250, that's right here, it looks like, which is slightly along the path. So we're going to take and we're going to draw a tie line now from here to here. So again, we used our initial composition as the pivot, and then we drew the tie line from the point where the isotherm touches the liquidous surface, and then through to the edge. So, say at 1250 degrees C, the fraction of solid going to be red. That's going to be, looks like about 10, 20, about 25 millimeter divided by around, let's call it 63 millimeter, right? So when you come to take the quiz, you're going to want to bring a ruler. It's handy. And then the fraction of liquid is equal to 1 minus the fraction of solid. The composition of the liquid, well, that's going to come from reading the place where the tie line cuts the liquidus. So that's going to be around 26% of SP, and around around 34% WO, and that makes that 60 makes it 40% of AN. Or we can get that from just drawing a line here, which looks about right. It's about 40% of AN. And again, I'm not going to show it here, but you use chemical formulas to get that, what the composition of the liquid is. And on the quiz, I'm going to want you to do that. So I'll pick a composition from this diagram, and I'll have you read the composition of the liquid based on the chemical formulas and the where the point is on the ternary diagram. By the way, for the quiz, it's going to be based on these diagrams, and that means that you're going to be able to take the problems that I'm showing you today and actually practice them. The quiz is going to be a little bit longer than normal just because it's going to require a lot of drawing and a lot of calculating, but it should be relatively straightforward based on what we're doing today. Okay, so we have this fraction of liquid, or fraction of solid, but the fraction of solid is now two phases. It is anorthorite and sphene. So if we want to talk about this solid, how much do we have of each phase? Well, we look at where our tie line is cutting the line between the sphene and the anorthorite. I cannot pronounce these. Anorthorite. Now, good news is this is a simple compositional triangle, right? It's an equilateral triangle, and we even have the numbers drawn out, which means that we have 10% SP and 90% AN. So I'm going to AN of that fraction of solid. So what you can do is, if you know the fraction of solid, you know the fraction of liquid, and you know that that fraction of solid is 10%, then you can say overall what the fraction of solid, of SP, AN, and liquid is in the system. again, this is working those numbers is left as an exercise to the reader. And actually, that would be kind of a handy quiz problem, wouldn't it? If I gave you exactly these and then wanted to see that you worked out the numbers on your own. Seemed like not a bad idea. So this is reading an example of reading from a simple ternary eutectic phase diagram. As we start out with a constant composition, we cool down, start out forming one phase plus liquid, and then form two phase plus liquid.